pocket computer holder? What am I talking about? Well, welcome to Shop Happenings. This is what we made. This is a pocket computer holder. What do I mean by that? Well, I can take my pocket computer, I can put it in my holder, and I can use it. Yeah, I know you call it a cell phone. I call it a pocket computer with phone capability. What we did is we made a piece of aluminum of a certain thickness and a certain size. We counterbored a hole so our screws can sit flat. We took a cylinder, made that to length, faced both ends, cut it, cut the truncation on, drilled a hole and tapped it for another screw. And that's also countersunk into a base of HDPE plastic. So there's what we have, a finished pocket computer. These are the drawings for the pocket computer holder. Yeah, I call it a pocket computer. I know everybody else calls it a cell phone. It's a pocket computer with phone capability. So these are the drawings my students get. They've learned how to read these and draw similar things throughout the year. This is a good project for us to look at. So cover page is real simple, gives you an isometric view and a side view, and lists the parts in a parts list. If we jump to the first part, I'll have them make, which is the base. It's all in aluminum. We start out with 3/8 inch stock right off the bat. They have to cut it to size, oversized, and then we have to machine all 4 edges, drill and countersink a hole. All the dimensions are here, as well as geometric dimensioning and tolerancing, which makes the drawing a little more cluttered, but students need to understand that that's a primary datum, and that happens to be our front plane, so it's this. It's going to be the bottom, in this case, of the part when it's done. We have a secondary plane, which is our right edge here, and our tertiary plane, which would be the bottom edge of our front. And it gives some parameters here. So students have to be accurate to within 5 thousandths. They have to understand that this has to be a flat plane within 5 thousandths. We throw it on a surface plate and measure that. We jump onto a surface plate again and measure perpendicularity of our secondary plane, and it also has to be within 5 thousandths of square. So that means that this edge right here has to be square. As I continue to look at this, this edge has to be perpendicular to both A and B. So this is A, this is B, this would be C here. So now the edge down here, everything is going to be square. It squares us up. And we also have a parallelism and a parallelism here, which would be parallel to B and parallel to C. So everything has to be really tight. It requires good setup and solid machining, and they are able to do that. The second part that they make, they jump around a little bit. We jump onto a lathe. We make this part. It's a cylinder with a truncation. I require my students to do the math, sine, cosine, and tangent, to figure out how deep we have to go to make that truncation. They have to do a lot of edge finding, and we use a collet block to do this. It works real well. We just go from one operation to the next with that collet block, and we can center that hole real nice. And again, there's a little bit of math here to go from edge finding this to the center of that hole. And it's fun to watch students do that. I really enjoy seeing them do that and work out that math. The last part they make, this is out of HDPE plastic. The unique part about this is there are sizes and squareness for the outside edge, but the inside just has a note that says they have to measure their pocket computer and get and add 50 thousandths to that pocket computer so that it'll fit in nicely. And we'll take a look at one of these here in a second.